So, welcome back. I hope you had a nice lunch, and welcome to this session, which is looking at frontiers of life sciences on aging. This is a rather different sort of session to the ones we've been having so far. It's more lengthy. We have 45 minutes, more relaxed, and I'm also looking forward to taking questions from the audience during this session. So I will be back to you soon. But first, let me introduce our three panelists for the session. We have Randy Sheckman and Tom Kirkwood, and also Yoshiko Takahashi from Kyoto University. Please join me in welcoming them. Yoshiko? Tom?
Okay.
Randy? Thank you. Yes, it's unfair. The announcer said no eating or drinking in the auditorium, but we're allowed to drink, it seems. Sorry. I wanted to start this session by focusing on something that, Randy, you brought up in your talk, which was Dario Alessi's comment on the climate for basic research funding, that there is money going to translational research, people trying to come up with shortcuts to cures, and not enough money for fundamental research. Would you like to expand on that at all?
Sure. Well, when I began my career back in the 1970s, I think there was a greater appreciation of the lack of basic knowledge about how cells grow and divide. And so I was able to get my initial funding from the U.S. National Institutes of Health, working on a simple organism, baker's yeast, to study the process of protein export, which is a process that's shared by all cells and a mechanism that is shared by all cells that have a nucleus. And I was able to work for many years with funding from the NIH with no particular evident useful direction other than just to advance the knowledge of how a cell works. And we made some useful discoveries, and as a result, with no emphasis whatsoever on translation, the discoveries that we made allowed the biotechnology industry to use yeast as a platform for the production and secretion of clinically important proteins, and now 1/3 of the world's supply of human recombinant insulin is made by secretion in yeast, something that I would never have done in my lab, but where the studies that we did allowed the biotechnology industry to employ that as a vehicle for protein production. And I fear increasingly governments around the world now really insist, some more than others, that research be grounded in some obvious practical application. And as a result, work on model organisms, yeast being one of them, is less well supported in the United States and I bet around the world. And I see that as a bad development because there are important discoveries yet to be made, and the discoveries are made more easily with organisms that have more manipulability, genetics and biochemistry. So I see this as a bad trend, and I speak out wherever I'm able. And in this case, as I discussed earlier, fortunately, Mr. Brin sees this apparently and agrees that really what we need is more basic science to understand where this disease, Parkinson's disease, begins. Without that, the drug discoveries will simply not be made.
Thank you. So we need more Mr. Brins. Yoshiko, you're a developmental biologist.
Yes, I am. Mm-hmm.
Is the same true in your field, that there's an underfunding in basic research these days?
Oh, yeah, absolutely. You see, I agree with what Randy said. And in Japan, too, it's unfortunately, the funding is going more and more toward translational or let's cure the disease. But I like to say that, for example, to understand what the cancer is, we really need to understand, for example, we need to understand what the embryonic cells are, because we now know that there are so many things shared by cancer cells and embryonic cells. Actually, cancer cells hijacked the mechanisms of the cell function. And this kind of, the basic research in different fields, they are intermingled in a healthy way. This is what it should be. This is my opinion.
And that's a widely held view among scientists. Scientists think that. But so why is the culture changing? Why is that not the obvious thing to fund?
Well, it's a quite delicate thing. Yeah. And we need to talk with the politicians. And also, I think it's a responsibility of scientists. And the scientists should be able to explain more clearly or try harder to convince people, including politicians, and then try to have ordinary people understand what the science is and what the scientific progresses are. Yeah, I think the both sides, the responsibility of the both sides, non-scientists and the scientists.
Thank you. Tom?
Yes, I think I agree with both the comments before. For me, when I began in science, the thing that motivated me, the thing that made me want to get up in the morning and go and do research was curiosity. And I think it's absolutely important that curiosity should be the main driving force of scientific research. I've been very fortunate through my career. I've always worked in publicly funded institutions, Research Council, the National Institute for Medical Research, and universities. So I fully accept that having received public funds, I should be ready to share the results of my research with the public so that people can appreciate why it's valuable to do this work. So I have no problem at all with being required to share, to communicate, to think about the impact of the research and to try to appreciate, understand that. But I think if you try to substitute the capacity for curiosity-led research with some sort of mission-led research, it can lead you into very unproductive ways of thinking, ways of doing science.
And perhaps especially so for aging, because aging seems to be a combination of mechanisms of action that cover the spectrum of almost everything we study in biology. And so it seems maybe it's a very good example of where you have to look everywhere in a curious way in order to make any progress. I don't know if you'd agree with that statement.
Yes, I think the thing that sort of perhaps is so distinctive about aging is just its sheer complexity. There are really interesting questions that you can address at the cellular, the molecular level, and then, as we heard this morning, there are big societal challenges. And actually, one of the things that's so exciting is that these all have crosstalk. They communicate with each other. But I think you have to be open to people making contributions of many different kinds. I think there's a particular challenge in aging research, which is how we put it all together. Sort of in my, I started working on the cellular and molecular mechanisms of aging, trying to understand what it is that makes cells age. And in the early days, there were a lot of different competing hypotheses. So you'd have people who would run around saying it's all due to mutations in DNA, and other people would say, no, it's all due to aggregation of proteins, and someone would say, no, it's about the mitochondria. And it was a little bit like being in a school playground where you had gangs fighting against each other. But actually, as I've pursued the research, you come to realize it's not this mechanism versus that mechanism versus the other mechanism. It's this mechanism and that mechanism and the other mechanism. So I think what you do need is some additional capacity to find ways of integrating the work that's being done. I think that's very relevant to what Andy was saying before lunch about the Parkinson's disease research, with a list of different mechanisms. All of them could be investigated in isolation, but they work together to produce this pathology.
Still, you have to start somewhere.
You have to start
somewhere. Unlike in the general problem of aging, which really is very complicated, with diseases like cancer or Parkinson's or Alzheimer's, there are genes. There are families with a predisposition to the disease because of a mutation that could be understood at a molecular level and a cellular level. So that's at least something to begin with.
Yeah. Mm.
But if we stay with this high-level view of trying to integrate multiple hypotheses, multiple different, if you like, research areas, is there a way of organizing that, the study of that complexity? I mean, I suppose setting up an aging research institute is a start and bringing in people who have the different...
Yeah.
But how do you do it? How do you go about it? Because in science, often people do pursue their individual hypothesis and make a career on that. And
I find, I mean, having been for 15 years director of a multidisciplinary research institute on aging, it actually requires quite hard work, because you've got to get people to kind of spend time, invest time in each other's company, talking to each other. There is a kind of science which can be done by focusing on an isolated problem, so the individual investigator in the lab can pursue things, and that produces some of the great discoveries. That's where many of the Nobel Prizes have been won. But in addition to that, you actually have to create an infrastructure in which people open their minds to what others around them are doing. And a different kind of challenge, a different kind of reward comes through doing science that way as well.
how easy is it to make people do that?
Everyone is an individual. Some people love it, take to it naturally. Some people will just never do it. They will want to continue to... And you have to create an environment that celebrates both ways of doing science. You know, there's no right way and no wrong way, but you do have to build the crosslinks.
What would you say, Yoshiko, from a Kyoto perspective, from a perhaps even wider, from a Japanese perspective, how easy is it to build that sort of environment?
Well, that's it's quite challenging, but actually, we are trying even harder now to go into this interdisciplinary, to create interdisciplinary fields. Then, let me speak a little bit of what Randy said this morning that impressed me very much. Randy beautifully showed a jigsaw puzzle in which even toward understanding Parkinson's disease, Randy emphasized that we need to have researchers from many different fields. I perfectly agree. But what impressed me the most is he showed a piece of jigsaw puzzle. Probably it said unknown field. Is that right?
The lower right-hand corner, yes.
That's right. And so then what I say is to understand Parkinson's disease, let's study mitochondria, the nucleus, and the epigenetics, blah, blah, blah. But he beautifully showed that unknown piece. That struck me. And the spirits, the important spirits of the basic scientists, the research, is that it means that we need to, even me, or we need to teach the younger generation how to create that unknown field. Mm-hmm. Well, this is the most important field, but again, back to the shortcut funding is kind of, it's like ignoring the importance of creating the non-keyword or an unexplored field. And I think I'd like to emphasize that kind of spirit in this panel discussion.
Thank you. Randy?
I'd like to amplify a point that you made about the importance of collaboration and building a culture of collaboration, because there's also a powerful force in academic science that works against collaboration, and that is the reward structure in academic science favors the individual who wins the Nobel Prize, or the individual who gets a research grant, or the individual who has a paper in Nature. So young scientists, in a way, are discouraged from collaboration because they can't accrue the kind of credit they need for advancement. So that's a cultural change in the way academic science must be changed, which in fact in industry, for example, in biotechnology industry, is less severe a problem because there it's the teamwork. It's the team that makes the difference. It's the team that makes the discovery. We need to build a culture in academic science that fosters that team spirit.
Yes, yes, I agree completely. And actually, it was a Nobel Prize winner. In 1904, the Nobel Prize for Physics was awarded to a British scientist, Lord Rayleigh. And he, in his Nobel lecture, said a sentence that I've often remembered, that when you're dealing with a challenging problem, you should neither seek nor avoid complexity in finding the appropriate solution to the problem at hand. So you don't want to make it more complicated than it needs to be, but if it is intrinsically complicated and you go for a simple solution, you will almost surely not get the answer that you want. And I think it's actually the nature of the science that really should direct how we try to find ways of tackling hard problems.
Thank you. Okay, I'm going to come to the audience for questions in just a couple of minutes, but we have you sitting there, Randy, and you are basically nowadays a disease researcher. And you have you sitting there, Tom, and you are an aging researcher. How much are you doing the same thing? How much is aging research, disease research, and vice versa? How much are they different?
I'll let you tackle that first.
Okay, well, I think what's in today's world, most medical research is concerned with problems, chronic diseases, for which age is by far the single biggest risk factor. Of course, there are illnesses, there are challenges in early life where developmental biology is really important. But if you look at Parkinson's disease, Alzheimer's disease, heart disease, cancer, there are genetic factors, yes, there are environmental factors, there are lifestyle factors, but when you compare those to the size of the contribution that comes from aging, aging completely dominates everything. And so the idea that diseases and aging are somehow separate seems to me to be a complete nonsense. And if we want to follow Randy's mission with this new foundation to understand Parkinson's disease, I'm absolutely 100% sure that a big part of the answer will come from understanding how the intrinsic processes of aging contribute to the development of that pathology. Would you agree?
Well, I not only agree, it's a little frightening, actually, to consider how as a scientist, you try to dissect a complicated problem. So, for instance, it's now possible to derive embryonic stem cells from either patient material or by directed genome editing, into which a mutation that causes Parkinson's disease may be introduced. And the hope has been that you could grow these cells in the laboratory and reproduce some aspect of the pathology. But what that ignores is the fact that these diseases only appear and advance with age. And the idea that you could then grow a cultured cell for decades before you begin to do an experiment is simply a non-starter.
Absolutely.
Good example. Thank you. Okay, questions from the audience. This is your chance. Please, don't be shy. Somebody must have a question. Goodness, what a polite group of people. Is nobody wanting to tackle this? You don't have to. Ah, good. Please, a microphone. You can speak in Japanese or English, but if you're going to speak in Japanese, you have to give us warning, because then we have to listen.
Hi, I will speak in English. Thank you. My name is Zachary from Kyoto University. I'd like to thank the panelists for a wonderful discussion. And I just have a question regarding the funding system in terms of, because please correct me if I'm wrong, but I have this idea that the people deciding the funding system or how much money to give to research, they are made up of economists, because the politicians are mainly economists. So they look at the dollars and cents, and they look at the immediate returns of the research, which is why I believe they are pursuing translational research, because they want a drug that works within 5 years. So in this sense, how much do like the top people in the research, the academic field actually discuss with the politicians when they are trying to set these guidelines, and how much money they should be setting aside? Because I think only researchers themselves understand how long it actually takes to even go to like a phase 1 or phase 2 clinical trial.
Thank you. Very nice question. Yoshiko, he's from your place. You should go first.
What a tough question. But actually, that's a very serious point. Thank you for your comments. Actually, I used to be in a council meeting of the Monbukagakusho, the mixed, to discuss with these issues. And I really try hard to emphasize the importance of funding to the basic scientists, basic research. And the members sitting there, they all agreed. But then now the next question is, why the funding situation doesn't change or goes in the wrong way? That's the question. The answer is, I don't know. And the simple answer, or quick answer, is that we need to ask the Ministry of Finance, 財務省. 財務省 is behind the Iron Curtain, you know. So then I really need to see these people. But actually, the president of Kyoto University, the president Yamagiwa, he tries very, very hard to discuss with 財務省 not only about how the Japanese funding system should be, but also about how the funding system to the national universities should be. Okay, so then don't give up. Let's just hold hope. This is all I can say.
Thank you. Tom and Randy, I mean, you're both advisors to research councils, advisors to government. Why don't they get it?
I think it's an excellent question. Thank you for the question. It's not only economists who decide these things. Usually governments have structures, the research councils in the UK, and people are appointed to those councils. So a small number of people will feed in ideas that could become a part of the priority of the policy. But perhaps it would be possible to generate mechanisms that would invite a little bit of upward flow, so the science community could have a mechanism to suggest ideas for consideration at a higher level. Sometimes programs come into being for quite arbitrary reasons. I have a friend who headed the Genome Project in the US Department of Energy, and he told me that the genesis, the origin of that project was quite extraordinary. The man who was at the Department of Energy, who was in charge of the biological division, was looking for a project that would be big enough in financial terms to appear as a line item, a separate item on the US federal budget. And he was trying to find a topic that would be of sufficient magnitude. And he heard about the prospect of sequencing the human genome. He did the sums and found that, yes, this would cost enough money to be big enough to be over the threshold. So I believe there is some truth in this story. It was a completely arbitrary origin. Sometimes things happen serendipitously and they turn out quite successfully. Sometimes, I guess, they screw up.
That's kind of depressing to learn, but at the same time, a happy ending in that case. But, yeah. Randy?
I'm not sure if this is true elsewhere, but in the United States, one of the biggest influences on congressional allocation is pressure from patient groups who advocate on behalf of their disease or their family members' disease. One of the most effective lobbying efforts some years ago was as the AIDS epidemic took shape. Lobbying in congressional offices was overwhelming, and the pressure was really quite remarkable, and that ensured that there was a great deal of investment into HIV research, which turned out to be a good thing. So often disease groups influence the path of funding. In the case of Parkinson's disease, for example, there's a powerful group in the US called the Michael J. Fox Foundation. Fox is an actor. He has Parkinson's disease. He's been a very effective advocate. And that organization receives a lot of charitable money, and they are influenced by their patient groups to fund clinical research as opposed to basic research, which in fact was one of the reasons that Sergey Brin decided to launch his own effort, because of his conviction that we needed basic science. So it's lobbying, and scientists are simply not as effective or as numerous as patient groups in lobbying. So it's a constant battle for attention and for education of congressional leaders to understand why we need basic science before we can achieve the discoveries that are relevant to disease.
Yeah. Yes, in Japanese case, we should remember that, for example, Yamanaka sensei of IPS, actually, Yamanaka-san and I, when we are Jokyoju, associate professors at the Institute of Nara Institute of Science and Technology, we overlapped, and we have known each other since then. And he started that research with, well, probably a relatively small amount of funding. Then he made a big discovery. Why? Because he had an idea, he had a passion, and also his students are very much curious, as you said, and that was very important. And let's think of Professor Osumi, also a Nobel laureate. He also discovered that big stuff in his what he said in his small lab with a relatively small amount of funding. So I think we should remember that way. So then the wonderful, striking discoveries, often they are born in a small group and a small size. So we don't necessarily need a big funding or a big, huge lab. And I think this is what the basic science is or should be. And again, this is what we like to emphasize, and to a politician and the ministries, we should be open for that. Yeah.
Thank you. Thank you very much indeed. Take another question in a second, but Tom, I just wanted to ask you, this session is called Frontiers of Life Sciences and Aging. What would you say was the frontier of research in aging at the moment? What are we seeking to push back most?
Well, I mean, we're learning quite a lot about different mechanisms. We're learning a lot about how metabolism is important in aging, because metabolic regulation seems to act on all of the different maintenance systems. So it kind of integrates. So I think one of the great frontiers here is how to develop that understanding of how central metabolic pathways regulate all of these different mechanisms. I'm, quite a large part of my work over the last 15, 20 years has been to develop a kind of systems understanding of the mechanisms of aging. And I think this is something actually where Japan has been a major innovator and sort of front runner in the development of systems biology to understand these kind of complex problems. So, I'm quite passionate about that as a way of dealing with things. But I think the other big frontier is the frontier we've mentioned already, which is the interrelationship between aging and age-related diseases. We have in the US the National Institutes of Health, many big institutes doing fabulous research on individual diseases, and we're beginning now to see the message spreading, saying, hey, wait a minute, what is it that aging brings to the story? In the UK, cancer, take cancer for an example. Cancer is a very important disease. There are many causes of cancer, but most cancers are strongly age-dependent. And in the UK, we have 6, 8 big, strong international institutes of cancer research. And if you ask how many researchers in those institutes are doing anything on the aging process, the answer is almost zero. And I think if we were to revisit this discussion 30 years, 50 years in the future, people in the future looking back on our period would say, how did it take them so long to wake up to what needs to be done?
Interesting. So aging is the elephant in the room. It's what nobody's speaking.
Yeah, absolutely.
Yeah. Okay. Another question, please. Yes, thank you. Lady here. Could we have the microphone? Sorry. Lady in the center here.
Thank you for your nice acknowledge us. So my name is Nurmila Sari. I'm from University of Shizuoka. So I have a question. As we already know that many research has been performed to overcome this aging problem. However, we keep aging until now. So my question is, we have many chronic disease used to stimulate by pathological stress, such as hypertension or etc. Do you think this is because of the aging caused pathological stimulation, or stimulation caused because of aging? Which is, do you think, first? So we have a chronic disease and so on. Thank you.
Which came first, the chicken or the egg?
It's a really excellent question. And I think the answer is actually it's a little bit of both. Because I think at the most fundamental level, damage happens in cells to cause problems. And so that leads to a loss of function. The population of cells that make up any organ system become slightly less good in their function. But some of that damage then gives rise to reactions to the damage, and some of those include inflammatory processes. And those inflammatory processes can become damaging themselves. So it's really important to try to carefully dissect what is cause and what is effect, and to understand that sometimes it involves even loops, feedback loops, that can make things a little bit worse. So I think it's a perfect question.
That requires a systems approach.
Absolutely.
Thank you. Another question, please. Yes, next door to you. So, if the microphone just goes that way, that's fine. Thank you.
Thank you. My name is Bin Bin. I'm from Yokohama National University. We always say science has no border, especially, I guess, in life science, because it benefits the whole human being. But however, I think it's always also affected by the politics, especially in nowadays, the US, Chinese government, and economics and politics, immigrations. And from this morning's talk, we all noticed that, for example, we're talking about the aging society. China, India, they are the two largest countries with largest population. Of course, the sample group would be huge, but we're lacking hearing the signs or the voice from them. So I'd like to know your comments on, are we facing a crisis of the politics influencing science so much, or from the scale of history, this is just common, and how we scientists should overcome this, the influence from politics? Thank you.
Thank you. What a fascinating question. Thank you. Okay. Do you want to go first, Randy?
Well, that's a complicated question. So let me try to focus on one issue, and that is the national boundaries that may limit the development of science. And I think the good news is, in China, for whatever political limitations they may have, in China, the government is investing enormous sums in science. And as a result, Chinese scholars have advanced really quite dramatically. I mean, my laboratory in California is virtually all Chinese postdoctoral fellows and graduate students, many of whom will go back to China, some of whom have already done that, to start their own laboratories. And as long as they are given the freedom to pursue their own curiosity, and so far what I've seen is pretty good in that respect, then Chinese science will blossom really very dramatically. Now, India is another story. The system of higher education in India is broken. And so very few students who get even PhDs in India have really significant experimental experience of the sort that I've seen among Chinese postdoctoral fellows. So they need to manage their educational system more effectively to train people, because the Indian people are enormously gifted. Those who have gone abroad early in their careers in the U.S. are incredibly bright and entrepreneurial. So they have the capacity, there's no question about it, but the system of higher education in India really limits their growth within that country.
So let me just separate two aspects of this. So that's on the question of different countries' contribution to the scientific enterprise.
Yeah.
And does it make a big difference if you get input from a diverse group of cultures? I mean, is science just one thing? Does it matter where the science comes from, or does it actually make science better to have a mixing of people from around the world?
I'll let other people address
Who would
that.
like to answer that? Do you think Yoshiko, what do you think? I mean, do you think a lab of... It's a very sensitive question. Do you think a lab of all Americans or all Japanese is necessarily sort of disadvantaged compared to a nice mix of people from all over the place who bring different ideas?
Well, it's quite a sensitive question.
And
my answer is yes and no. And the yes side is that, of course, diversity is very important, very important. Because I did a first postdoc in France and the second postdoc in US. And through these experiences, how much I learned that I couldn't have learned if I had stayed in Japan, okay? I really experienced. And the no side is that, let's say, if my lab has so many foreigners who don't understand Japanese, then the language problem is really high, really high. Maybe you guys thought, maybe you might not understand, but for us, Japanese, language hurdle is very high. So then the important thing is that we really need to be able to think logically in our mother tongue. Yes, and this is number one. And let's go abroad and let's become global. So I think it's a very complicated the issue. But in general, I am always open to the young people coming from any countries, I personally.
And there is a flip side to the coin, which is that there may be particular ways of doing things, and I've heard this expounded by people from different countries, saying that actually there is a particular, for instance, Japanese way of doing science, which you should not lose by dilution, because there's a particular way of thinking about things that is true of many different countries. So it is a very complicated and sensitive question. Yeah. But now getting back to the political issue raised in the question, are politics playing havoc with the data, the access to the information, the ability to really understand the problem on a global scale? Tom?
It depends what kind of science you're doing. In the areas of science where I work, I don't think politics is a barrier, as a problem. We heard earlier in the day about the problems of data quality for some population-based studies. And for those, you need government to invest in infrastructure to collect data and to ensure the integrity and the quality of the data. So politics does come into it in that context. But I think in the life sciences and the laboratory sciences, I would say that that's less of a problem.
May I add a slightly different aspect of this, and that is commerce can influence and impede the sharing of information. And here I'm going to make a pitch for open access publications, in which all information is freely available to anyone wherever they are. The commercial forces that oppose the spread of open access publications are very powerful. The journals published by commercial outfits have branded themselves very effectively, and they oppose open access. And yet you, as taxpayers here in the room, have funded the research that your investigators have conducted, and yet you may not, unless you have special privileges, have access to that literature. And so that is a barrier, I think, to the spread of information around the world, particularly affecting nations that have poor economies.
Thank you. So, another question? And publishing is fair game. Yes, please, here. There's another one up there, but yes. Yes, please.
Thank you very much. My name is Fajar. I'm from Tokyo Institute of Technology. So my question is, ever since the talk since this morning and today, you people talk about the detrimental effect of aging. So my question is the other way around. Is there any circumstance where aging actually has a beneficial effect in terms of cellular, if cellularly speaking, or in terms of society? Thank you very much.
Let's talk about the cellular benefits of aging, first of all. What does it protect us against?
It's a very interesting question. You can see it's making us think. There is an argument that limited cell division capacity is protective against cancer. There would be other ways of protecting against cancer by having better repair mechanisms, better protection mechanisms. But given that aging is happening anyway, given that damage is accumulating in cells, cells respond to that in ways that are related to aging and that are protective of the organism. So, for example, apoptosis, programmed cell death, is a mechanism for the body to get rid of cells it doesn't want. Now, that's important in development because it's a part of the shaping of the body. But in the context of aging, when cells are badly damaged, if those cells are critical, like stem cells, you want to kill them. Because otherwise, if you keep them, they could give you a cancer. And the same is true of the phenomenon of senescence, replicative senescence. But that's a benefit, not really of aging, it's a strategy to cope with aging. So I don't think it's really ultimately a benefit of aging. Right.
And there's nothing from studies of centenarians or super centenarians which shows that there's something special going on, that sort of, once you get, these people who have this gift.
I don't think so. I mean, I think another part of the question was whether there were societal benefits of aging, and that's a much more complex and interesting question. You know, if we have to die, we do have to die with our current biology, then you could say that a part of the aging process is a process in which you have to accept functional limitations. You have to come to terms with the processes that will ultimately bring about the end of your life. And a lot of our literature, a lot of our culture, a lot of our music, a lot of everything has been generated as a kind of psychological, as a societal response to aging. So you could say that the presence of aging as part of the human experience of life has enriched us in some ways. I'm not sure I'm the person to go very profoundly into that.
That was quite
But I think
profound.
it's an interesting question, yeah.
That was good.
Can I speak a little bit? Because I'm more excited if I can speak of the science. And before coming here, I read a very interesting article or articles. It's a good news for you. If there's a mouse A and a mouse B, and if you combine these mouse A and mouse B with blood vessels.
Yes.
Oh, mouse A, young mouse A and old mouse B. And if the old mouse B has the circulation, the blood cells from the young mouse A, then the old mouse becomes younger. Isn't that good for you? But it doesn't necessarily automatically mean that you can just drink the blood from young people. Don't do that. But it gave us a very good insights, and the researchers are working very hard. I'm not super familiar with this work. I'm a developmental biologist, but this work, I think this is wonderful. However, what kind of the components in the blood is the factor that rejuvenate the old mouse. This is what the researchers have to find out. Then for that direction, again, I like to emphasize that cell biology or basic science, basic research is absolutely necessary to explore this good news much further. Well, this is.
Thank you very much. Well, fantastic. Miserably, I realise we're out of time, which is because we seem to have ended the session on advocating vampirism, which I suppose is as good a way to end as any. It's been a really fascinating discussion. Thank you to all my panelists. Thank you to all of you.
Okay. Thank you.
Hello again, everybody. Welcome. So welcome to this panel on healthy aging. And for this one, we have Liz Blackburn and Tom Kirkwood, who you've met already. And please join me in welcoming Professor Hiroshi Ito, who's Professor and Chairman of the University School of Medicine at Keio University. Tom, do you want to sit at the end this time?
Okay.
Professor Ito.
Okay.
Yeah. Liz, do you want to sit next to me? Thank you. Well, hi, everybody. Hands up if you were in the last session in this room, please. Were you here? Okay, that's a kind of, yeah, thank you very much, that's helpful. So some of you heard the discussions before, some of you didn't. This session is dedicated, the last session was dedicated to life sciences and aging. This one is dedicated to healthy aging, something we all hope to do, to age healthily. Let's start by asking the question, what do we mean by healthy aging? Liz, how do you take healthy aging?
I think there's a positive and a negative. The positive is that one is happy, engaged, seeing reason and purpose for life. And the negative, of course, is the absence of particularly disease, but also the absence of, the sort of, loneliness and depression and things like that can go along with old age. So two kinds of ways of looking at it, both avoiding something and positively gaining something.
Thank you. Professor Ito.
Yes.
What do you understand by the phrase healthy aging?
So I'm a doctor, so from my point of view, it's maybe the state of without disease, or the people who can live alone without any support from other peoples. But I think a healthy has a big word and can contain more. For example, I prefer the word well-being. That's more, a good word for the healthy, the more big word of healthy.
Thank you. And Tom?
Yes, I think I would agree. I think it's a capacity to enjoy life in spite of the fact that you may have some illnesses. So it's a little bit paradoxical, but then aging brings illness and you can still be healthy.
Yes, because inevitably people will have health problems as they age. Yeah. Indeed, you did this study of older people in Newcastle in the United Kingdom.
Yes, we found this was a study called the Newcastle 85+ study, and we approached everybody in Newcastle who was born in the year 1921. We started the study in 2006, so the year of their 85th birthday. And we were able, it was a very comprehensive assessment for each individual, for each person. We could find out whether they had or did not have any of 18 different illnesses. And what we found was that 3/4, 75% of people at age 85 had 4 or more illnesses. So there was a lot of what is called multimorbidity. But then we asked them a very interesting question. We said, tell us, how would you rate your health compared to other people your own age? And we found that 78% of them, so that's nearly 4 out of every 5, self-rated their health as being good, very good, or excellent. So it's paradoxical. A lot of illness, but actually they're enjoying life and can say that their health is good or excellent.
So,
yes, please.
Yes, in Japan, the centenarians over 100 years old is about 60,000 people, and the supercentenarian is over 110 years old is about 160. And our university has the Center for the Centenarian People Research. And because according to our survey, the incidence of diabetes and cancer is very low in these centenarians. So in that sense, to live longer we should avoid from these diseases such as diabetes and cancer, and they are free from these diseases. Then they can live longer.
Right, that's an interesting finding that they're protected and therefore they live longer.
That's correct.
We were also touching on another question, which is how we measure the progress of aging. Partly, age is a is just a self-assessment of happiness then and well-being, as in the Newcastle study. But how good are we at measuring how aging is progressing? I mean, Liz, from the question, one very direct measure is the length of the telomeres.
At a population level, yes, there's tremendous variation at individual levels. So we have to be very careful that when we look at population trends for how much telomeres are wearing down with life, which directly does in turn predict population probabilities of future cardiovascular, future diabetes, even future dementias, interestingly, that is a purely statistical measure. And yet what we're all experiencing is individual experiences of, these subjective feelings that we're talking about. So we have to be a little bit careful to use those kinds of information appropriately. I think the sort of information you get from telomeres, frankly, is the sort of information that's useful for making, having a guideline in an objective way for certain, say, policy decisions. If I'm doing such and such a policy that has such and such a societal effect, there's going to be a measurable effect on telomere maintenance at a population level. That in turn will translate into a measurable probability at a population level of incidence of certain chronic diseases. If you're looking at the finances of a health system, that's the sort of information you may want to know. As an individual, your telomere length does a lot of changes throughout life. We've studied it very carefully in individuals. There's a lot of bouncing up and down. If you have very short telomeres, that's one thing, but it's not specially predictive for the most of the population for individuals. But that said, if we look at ourselves as a species and sort of step back and say, well, what about us as populations? That's where I think we can gain some real information. On the other hand, we can also really look at that and say, well, that gives us guidelines for health practices that we individually can look at, and they include everything we've heard about earlier, exercise and good sleep patterns, all the things we heard about for cognitive health. All of those we see increase better maintenance of telomeres. You get positive effects on telomeres for resilience, for exercise, for good sleep patterns, for Mediterranean type of diets, for social support, all those kinds of things. So it's a marker, but it's also a contributor to processes of aging. So I think putting it where it should be put is useful, but one can't, just say it's everything. But we can, if we understand where to deploy it, it can be a useful measure.
Tom, do you want to comment on how you measure aging?
Well, to be honest, it's something extremely frustrating because it's not easy. It's quite interesting. This year is the 50th anniversary. In 1969, there was a paper published in the top medical journal, The Lancet, by a British gerontologist, Alex Comfort. And the title of the paper was A Test Battery to Measure the Rate of Human Aging. I wish I could say that in the 50 years since he published that paper, the problem had been solved. But actually, it's incredibly difficult. And even with Liz's wonderful discovery of telomeres and telomerase, we actually still don't have any really good single measure of the rate of aging. In the Newcastle 85+ study we mentioned earlier, we found that it was necessary to create an index similar to what Comfort was proposing with 74 different items. And that gave us a capacity to predict who would survive a long time and who would die quite soon. But 74 items, it's hopeless. So what I'm hoping is that some smart woman or man in the audience here is going to crack the problem of measuring aging rate. And a few years in the future, we could have this discussion with the answer immediately available to us.
Fantastic. Feel free to leave if you want to just go and do that now.
Go do that.
So from the point of the doctors, we put more importance on the appearance of the patients. So it's seems to be non-scientific, but I think, one's appearance is very important, and we can measure the change of the appearance, for example, by the visual techniques, by IT learning, something like that. So it's very difficult, and it sounds to be a little bit silly, but I think the overall atmosphere or the feeling of the one's appearance is very important, I think.
Right. So as a doctor, that's what you go on, is it?
But I think you have to also think about what are the things you're looking at. And I'll give a very specific example. I know a wonderful woman in Paris who, is a researcher, right? And she's very, she's elderly. So she, her back is very stooped, right? So you say, well, she's got, check disease, osteoporosis or something. Her hair is very white and so forth. But, if I spend an afternoon with her, going to museums and things, I'm just exhausted, begging to be let, and she's still full of energy.
Yeah.
And so if you looked at many of her outward appearances, you would say, gosh, this really is an old woman, and that you compared with me, but she has great stamina, and, well, she lives up 5 floors, so every day she's going up 5 floors just to get home to her apartment. But that's, so she's getting exercise. But so I think that's the thing. We maybe, like you were discussing earlier in terms of there being many kinds of Parkinson's and many kinds of cancers, maybe there's many kinds of aging, and we're making a mistake calling it one thing. But on the other hand, you would look at her probably at a physician, and you'd see all the bones and the hair, but her face is very cheerful. See, that's the interesting thing. Yes, her demeanor is very
active is very important.
That's right. But she's also very involved with, students from overseas and things like that. So she has a great purpose in her life, even though she's retired. So it's only one case, but I think it encapsulates what, to me, I'd say she's one of the healthiest ages I know. But she looks really old, white hair, stooped and everything.
Well, that's fascinating. And we could stay on this, but I think we have quite a lot to get through on this session. I also want to take questions from the audience. So you mentioned there that exercise is very important. There are many lifestyle, there are many aspects of lifestyle that we know impact aging. And we all, I suppose, to a greater or lesser extent, try to avoid aging by doing things. How much do we understand about the interconnections between our lifestyles and the aging process? I mean, there's some very straightforward things like exercise will perhaps help us not get heart disease, but how well do we understand the way they link together?
Well, I think as has been talked about, we're immensely complex systems, but there are pathways through which things work. And so I'll take my field just as an example, but not to say that this is exhaustive. But when people exercise, their stress hormones go down. We know that certain stress hormones damp telomerase in immune system cells. That, in turn, will long-term damp down telomere maintenance. But I wouldn't by any means say that is the major or only pathway. I'm just saying it's a good example of a pathway where you can connect some dots, all the way from brain to stress to the effect of the stress hormone being received by receptors in the cell that goes in, and then you affect the expression of telomerase. So you can see pathways. But we know it's going to be immensely complex, and I keep wondering if we really do need to be focusing on all the hundreds and millions of different things going on, so much as trying to extract which are the really important ones. Understanding there'll be immense complexity, but trying to say, well, which ones quantitatively matter, and which ones probably matter most for individuals, because we really know that they will play out differently in individuals. So I think developing tools whereby individuals can be seeing how things are affecting them. We call it personalized medicine. I'd call it personalized prevention, personalized health. And I think there's a lot of advances going on where people are wearing devices, understanding what's going on in them. I wear one of these devices, and it's fascinating. You really can see what things are influencing resting heart rate and sleep patterns. And so you're getting as an N=1 longitudinal experiment. So it might be that individuals can really start taking a lot of things on themselves. where we can get away from averages, but each person enjoy sort of watching what's going on.
But dissecting all this apart is a lovely idea, but I mean, with 74 measures of aging, but then many more potential lifestyle influences, how do you begin?
Well, I think it is quite challenging. I mean, exercise, we've heard about, I think, happiness, sort of psychological orientation is important. One of the things, to my mind, that is so important, and we don't yet understand, but we really need to understand, is what it is about the socioeconomic gradient in the population that has such a big impact on aging. Because we know in every country in the world, the people who belong to the highest socioeconomic group will live longer on the average and will become sick at a later, older age than people in the lower socioeconomic group. And what is it about being in one group than another? It's not just money, because you can live in a country which has a free healthcare system like the UK, free education, exercise, you can exercise for free, you can eat, even if you've got limited money, you can still eat quite healthily. But psychology, I think, is quite an important part, because people who are at the lowest end of the social spectrum have actually a very low sense of self-worth. They have low aspiration for themselves, and I think the negative psychology also contributes. So this is not really to answer your question, how do we measure it, but it's saying that this is desperately important. In the UK, the difference in life expectancy between the top and the bottom end is 10 years, more than 10 years.
Is that replicated around the world?
Yeah, in the US,
yes,
that's true.
Yes,
Yep.
I mean, it's I don't know the numbers for Japan. But
I think the chance to know one's status, physically and mentally, is very important. It really bit related to the socioeconomic problems.
Yeah.
For example, hypertension field. If you know your blood pressure, just to know that blood pressure itself decrease the blood pressure of his or her. So to know the fact that our own state is very important, and it's very difficult to achieve for all people to do that.
I think education has proven over and over again to be something that I collaborate with people where we do measures with various things that people look at, and the term resilience comes up a lot, which is, perhaps education is one form of gaining, resilience is a very broad term, but it's a very useful one, because over and over again, we keep finding that, well, for example, when people, do self-reports of resilience, and we measure this against telomeres in cohorts of people in the various situations, we see that it tracks with how short their telomeres are, the less resilience they have. And you can turn it around and you could say, well, some people will have equal external stressful situations, but when you put the resilience measures there, it's the resilience that will have an effect. Sadly, not always. It's not always enough to overcome, very bad social, for example, or family situations. But I think that's a term that we could perhaps run with and say, what are the things that increase resilience? And that can capture, maybe sleep is important for some people, but maybe exercise is more important for others. We don't know which the major components of resilience are, and in different times of our life. Because we treat it as though it's uniform, but what's good for 20 and 30-year-olds may not be good for 50 or years, which might not be good for 90-year-olds. We have to look at them each, I think.
Yeah, it depends on the individuals. So we
and
have to know that
stage,
each person's real stage.
Yeah, and it may change throughout life. I'm sure we've all noticed changes as we get older that we just wouldn't have put up with when we were younger. So,
we all preserve the idea that we're the same, though. We fundamentally want
well,
to
it's a useful thing when, in the absence of other information.
Yes,
it's a good first start. But I don't think we have to resign ourselves to that. any longer, because I think now the technology is there. We can do much better. You know, you work with the tools you've got.
Just on that thing of being the same, I just reminded me of a thing. I once watched a group of 20-year-old students, about 200 of them, talking to Rudy Marcus, a Nobel laureate, who I think at that time was in his late 70s. And he said to them, you know, you're all sitting there looking at me and thinking, goodness, you're so old. How can anybody be that old?
Right.
And he said, what you don't realize is that I feel in my head exactly the same as you do.
Yes.
And I don't know, I mean, there is an element to which people feel the same throughout their lives.
And people say those who feel old, it correspondingly plays out in older, well, perhaps you can speak to that. So again, as Tom was saying, the mind is a really major driver of so many things. And I think, you know, my sense is that medicine had so many challenges. There were so many awful things that one had to deal with, like infectious diseases and, you know, wounds. And I mean, there were so many dramatic things that we just had to take care of all those things which were to do with our physical body. And now we have the luxury to start looking at the things that are affecting us long term, and we can now start to see how important our mind and our brain is in being a major driver of so many things that were just not the preoccupation of medicine, because there were so many other things that had to be dealt with.
Absolutely. Thank you. Let's take some questions from the audience. Please, who has a question? One back here, please. Microphone, please. Hello? Can we take a microphone? Quick, there. Thank you. Oh, the lady, yeah, behind you, up there, upstairs. I see you here as well. Yeah, I'll come to you next.
Hello. Thank you for the panelists for inspiring discussion. My name is Kao. I'm from the University of Tokyo. I have one question. Does a reproduction process affect the aging speed or the life expectancy, both physically and psychologically, on both women and men? Thank you.
Can I answer that one?
You can.
Because there's a wonderful study in a species called the naked mole rats, which are highly social, long-lived African species of very social animals. And the mother naked mole rats can produce several hundred offspring. They have a very long lifespan, which is the same, pretty much, lifespan as, you know, the workers and the non-reproductive mice. So, not mice, sorry, naked mole rats. So there may be in some species what's called a trade-off, but here's a species where there seems to be no trade-off. So, and I know in C. elegans worms, there are mutations where you can clearly show that there's a lack of coupling of the trade-off of longer life and reproductive ability and capacity. So it seems to work in some situations, but like everything else, I think the idea that it is inexorable, that it's inevitable, that it's a requirement, that has been, when you see that there are cases when it doesn't apply, then I would say, then you have to say, you have to rethink that it's always going to be a trade-off. I don't know how it works in humans.
Tom, aside from naked mole rats?
It's a very interesting question. It used to be believed that sex shortened your life. Sigmund Freud, the founder of the School of Psychoanalysis, firmly believed this was the case. And in England in the 17th century, there was a poet, a very famous poet, John Donne, who wrote a poem. This would be difficult to translate, but he wrote, "Since each such act, they say, diminisheth, shortens the length of life a day, I'll no more dote and run to pursue things which hath indamaged me." So to put that into modern English, he's saying it was believed that each sex act, each time you had sex, it would shorten your life by a day. And as a young man, he had been very sexually active, but in later life he became a priest and he decided to stop having sex. Now,
it's called fake news, Tom.
Yeah, this is an idea. This is an idea which actually has some currency. If you are a fruit fly, it shortens your life. Sex shortens your life.
But we're not fruit flies.
For humans, it does not. So you can relax. For humans, it does not shorten your life. Nevertheless, there is an interesting relationship between fertility and longevity. And some 20 years ago, together with a Dutch epidemiologist, Rudy Westendorp, I conducted a study of the English aristocracy going back over a number of centuries. And what we found was that those aristocratic women who died at the oldest ages had fewer children and had greater problems with fertility. And this is predicted by biology because you predict that there would be a genetic trade-off between fertility and longevity. It's a complicated thing to investigate, but it has been confirmed in a recent study in the US. The Framingham study, the big epidemiological study, shows a similar relationship. So we know that in the population there is genetic variation for longevity. Not huge, but we know that there is genetic variation. So, you may have a genome which predisposes you to live longer than I have, but there is a trade-off that it seems that if you've got a genome that predisposes you to high longevity, it probably predisposes you to lower fertility. So that's a trade-off between longevity and fertility, but it's not the same as saying that sex, the act of sexual reproduction, shortens your lifespan. It does not. So it's complicated and interesting.
Complicated, fascinating, interesting question. Thank you very much indeed. Another question here, yes, please.
Thank you very much for that interesting discussion. My question is about the psychological state of people who live very long. In addition to the fact that they have lower propensities to, say, cancer or diabetes, they kind of, if they don't have cancer or diabetes, they tend to stay alive longer. But what are the common psychological factors that long-lived people share, or are there any common psychological factors? Because just one more point. So these people have been through, like, say, a world war or like, really difficult life circumstances. So what have been their common coping mechanisms that...
We have data for the survey of our center, and almost every centenarians and super centenarians, when we asked them, do you feel happy? Almost all people answer yes. So they feel happy. So this is the, because they lived long, they feel happy. It's not. Because they feel happy, they can live long. Can you understand? So happier people live longer. So the sense of happiness should be one of the factors for prolonging our life. So, but to be happy, it depends on the individuals, I think.
Can you say anything further about their life circumstances? Have they had easier lives, more difficult lives, more children, less children? Is there anything you can say as a...
Yeah, their impression is that they feel happy because they are connected with others.
Okay.
So if we have many children, what's one way to be to make the more chances to be connected? So it's one way, I think.
Thank you. Another question down here, please. Sorry. I see you there, but just one here. Well, I'll tell you what. Okay, we'll go there first and then come to you because that's the route of the microphone. Thank you.
Thank you for the opportunity. It's an interesting discussion about how lifestyle can affect aging or longevity. So there is a current trend about research about a human gut microbe. Yeah. So I would like to know your opinions, the link between a human gut microbiome and telomere length and telomere function in our body. Yeah. Is there study about the link between physiological, like stressful life, with the diversity of bacteria in our body?
Thank you very much.
Yeah.
Thank you.
It's a question just waiting to be asked. Yeah, it's a terrific question, because the microbiome question has just opened up questions, and I'm sure people will be studying that. But to date, I don't know of any studies that have been informative, directly related to that. And it's going to be a great question to look at that multifaceted aspect of our physiology and how that intersects with healthy aging. So you young scientists, there's lots of great questions to ask.
And maybe all we can say now is that we have the data for the survey of diverse centenarians. Their microgut biome is quite different from ours. We don't know that's the cause of the results.
Yes, that's been the problem with much of the microbiome or microbiota data has been frustrating in the sense that there have been terrific observations made, but very hard to know what is driving what. I mean, there's certainly been some very good studies where people will transplant, microbiological components from into recipients and see effect. So you can definitely say there's a causality in those ones. But what we observe in the naturalistic experiments, I think, is still largely at the observational stage. But really important, because that microbiome, there are species in there that are just playing our physiology like a violin. There are species that can go in and work on our inflammatory pathways and cause whether we get, muscle wasting when there's a disease or psychological effects. So this evolution that's gone on, co-evolution in us, has been, they've been playing with us all of these millions of years and working with us in ways that are, obviously evolutionary to the microbiome advantage, because they want to keep us alive.
So there's a great explosion in interest in the microbiome. Yes. I mean, how, if you were in charge of the funding, would you give more to it? Do you believe in this absolute sort of fascination with it, or do you think it's a bit overblown? What do you think?
Whenever there's a new idea, then there's an explosion of interest, because I think in humans we just want to say, let's ask all the questions we can, because a whole new angle on something opened up. It was like telomeres. Everybody ask all these questions about it, and then you start to see where it fits in the bigger picture. It'll be the same with the microbiome. But I think we're just curious people. We're just curious about this. We'd love to know how this plays in with all of us, because, we were very kind of human, human's the only thing that's important, and lo and behold, our microbiome, by the way, weighs about the same in our body as our brain. So just think about that. We have about 1.5 kilograms of brain and about 1.5 kilograms of microbiome. So, we better understand how that works.
Tom, do you want to touch on the microbiome?
No, I haven't really anything much to add. Your question about, sort of this as a research field, I'm slightly hesitant, because I think it's one of those fields where it's terribly easy to gather huge amounts of data, but actually I grew up in a time of science when research questions were driven by hypotheses rather than the collection of data. Now, I do believe that gathering data can lead to new insight, but I think there is a problem with this research, that the research question is very often invented afterwards rather than guiding the research.
But now in the microbiome field, I'm happy to say that there is some terrific, very, very insightful kind of things along those lines. Yeah. So I think the two will play off. But we mostly hear about the big data part because it's sort of new. That's I think we're fascinated by the new. I don't know how much money I'd put onto it per se, because if it's really good science, then you hope that's where the funding follows, and it's the good science that is being the primary driver of where the money goes. And that's what the National Institutes of Health were really, had very good ways of assessing what was really good science. And that, we feel is not quite so good as it was now, but the capacity is there to judge what is really, really high quality, innovative or creative science and, put the funding there. So we heard earlier about basic science, and I absolutely agree that's where the money is much the best spent.
My dream or my expectation is that to find out the unknown metabolites which the gut microbiome can produce and which can prolong our life.
Yes.
There are some possibility there.
Right. I mean, so we don't know where this will lead, and that's why it should be investigated. But I think if you went in and said the microbiome is going to be the secret to long life, I think you might be doomed to disappointment. And, but we don't know.
At least. Yes. Yes. Thank you. Please.
Well, thank you very much for really interesting sessions. I have two short questions. First one is to the Professor Blackburn. You mentioned about this old French woman, and would you say the face of the woman is look much younger than her age? What would you say?
Yes, and there have been twin studies done where people ask people to look at a pair of twins, identical twins, and look at their faces, and then they ask them to predict who's going to live longer. And humans are really good at this. And this study was done, I think it was Swedish studies.
No,
maybe
it's
more.
Danish. It's a Danish twin
yes,
study.
That's right.
That's the thing I was reading.
Yes, good. Okay. So I think that we as humans integrate a tremendous amount of subtle information, and that's a good biomarker. Just what the face
I think
looks
it's a
like.
Phenotype.
It's a phenotype.
It's a phenotype.
Yes, it's a phenotype.
So the second question is that would you? We can't really gauge the speed of aging, but the face, how you look, is really one thing we may be looking for studies and in the future.
Professor Ito was saying that.
I think AI, artificial intelligence technique, is very, I think, crucial for this point. So we gather many data on the faces, and we can trace the disease onset or her fate, and then we can extract some essential information from that. So visual technology is now very much advanced. I think it's one of the.
Do you think it's static, or it has to be animated as well? Because is there an animation if you took a single snapshot, as opposed to letting somebody, or you would see the animation, or otherwise? I don't know.
So during our daily dive, then we can take some pictures.
Has quite a sinister overtone, though. The idea that the state could be watching, deciding when, and insurance companies and everybody else.
Yes, that's the two-edged sword with all of this kind of information. I think that we, as a society, we have to grapple with that and make some decisions about what gets regulated in terms of what information gets used for what purposes. And that means, really sort of coming in as democracies and making those kinds of clear decisions. We've been sort of misled by tech companies, and we've seen how that can get misused, and that's at a commercial side. So it's kind of time to take back control in some ways. I don't mean populist kinds of things either.
Especially in our hospital activities, we want to record the behavior and the conversation tone or something of the patients when he or she entered the office. And such kind of a record is very crucial for the the prediction of the patients.
Yeah.
Really?
Yeah.
Okay.
Well, it's a deep phenotyping in a way. It's a very detailed phenotype, I think. Yeah.
Thank you. Questions? Some at the back here, yes. Please, there's a person here, yes? Sorry, there are lots of lovely questions. So.
Hello.
Thank you.
Thank you very much to all the panel people. It's really information. The information you share is really, really inspiring. My name is Anshu, and I'm from India. I have a question from Professor Ito. As he mentioned earlier in the start of the session, that there are many sanitarians who have been here in Japan, and many hundreds of them are still a super sanitarian who doesn't have the sign of diabetes or cancers. And it's a follow-up question from the previous one, that have you ever noticed or have any information about, can they still develop these kind of disease or diabetes or cancer related after a certain age? Or are they still prone to have these diseases? Or it could be, again, an aging beneficial factor, as we have a last question in the earlier session, that they, after a certain age, that they do not have, or the body doesn't have the capability to still develop this diabetes and cancer, which is advantage for them.
Thank you.
Thank you.
So are these centenarians and supercentenarians actually protected from these diseases so they will not develop them?
So about 5% of the centenarians are suffering from diabetes. So usually the incidence ratio of diabetes is about 10 to 20 in our general population. So the occurrence is very low in this.
But for instance, cancer, do you see cancer developing in people who are that old? Or is it, if they're free from cancer once they get to be centenarians, do they stay free from cancer?
The occurrence of cancer is very low anyway. And even the cancer occurs, it grows very slow.
Okay.
So it's not life-threatening.
Okay. So, there you are. Thank you. Another question, please. There's a question here. I see you here, but just while the microphone's up there, in the middle of the room.
Thank you, panelists, for your inspiring talk. I just have one simple question. Do you think that people aging at the same rate biologically and psychologically? Yes, thank you.
Sorry.
Do people age at the same rates physically and psychologically? No. That's easy.
Do you want to add one sentence to your no?
And I think that there's a lot of control that, there's a lot of ways that can be changed, and some of which we have individually in our control, and some of which I think we need to think about societal influences like access to education, like access to, good food and good conditions, prenatal care, for example. There are a lot of ways that decisions made at the level of societies will affect these parameters, which in turn affect how we age.
Thank you.
In the morning, so there is the problem raised that the gap between the life expectancy and happy life expectancy, and there are 10 years difference in Japan. Yeah. So, but I think still diseased people or the people who have the disease can feel happy. So I think happy life expectancy is the most important thing. So the physically intact and the mentally is not is the crucial thing. I think the feeling happy is the most important thing.
Thank you.
Because we always think of aging as a physical parameter, and yet you're saying if you think of aging as a psychological parameter, maybe many people actually don't age very much at all in their minds, but some do.
I think maybe we're on to the last question, but I think there was a question here. Please, excuse me. Microphone. Hello. Here, please. Down here.
Down.
Sorry, down here. Sorry. Thank you.
Been a beautiful day. Thank you very much. Faro, I'm a JSPS fellow at the University of Tokyo. So many lifestyle decisions and circumstances lead to chronic diseases, which affect your aging. But apart from that, do you think aging to the core is actually a telomere problem? What if we hijack cell senescence?
Yep, it's a great question. So if you could make your telomere maintenance perfect, would you then cease to age? If you're a cell growing in a dish, that's, yes, other things being equal, you could keep cells going. But I think First of all, other physical changes do happen. In centenarians, people have looked at telomere length, and those who are physically sick, perhaps the ones with diabetes, I'm not sure what the illnesses were, and those who are physically healthy, there's clearly a difference in the telomere length, even in the centenarians. But they still die. And so I think that, I look at it a little bit like this. I think telomere maintenance, kind of think of it as a little bit like breathing. If you want to live a long life, you better keep breathing, right? If you want to live a long life, you better keep your telomere maintenance good, but that's not going to save you from whatever it is about our systems that in the end, lead us to die, sometimes rather quickly and precipitately, and in the case of healthy centenarians, quite quickly there'll be a sort of systems failure, and your telomeres don't save you from that, but they keep you going and increase your health span. So it's part of the picture, but it's not going to be the thing that'll keep you going forever.
Thank you. Nice question. Thank you. Okay, we are out of time, but I just want to ask my panelists before we go what their tip for healthy aging might be, either for you or perhaps for the elderly people that you are connected with, that you can inspire them with. So, tip for healthy aging.
Stay curious.
That's nice. Professor Ito?
Please think that happy people can live longer.
I'd say be positive and be flexible because aging is an unexpected journey and you have to be prepared to deal with the unforeseen, the unexpected.
Adapt.
Curious, happy, flexibility. Sounds like a Nobel laureate to me. Thank you.
Thank you. Thank you. Thank you.
Now we would like